Hello, welcome back to whatever this is called. Okay. Uh okay, so last time we left off, I ended with the polyatomic ions, right? Okay, so let's just revise ionic bonding, the polyatomic and the transition elements. Okay, let's get straight into it. You know what? Why not revise both transition elements and what is it? And the polyatomic ions in the same one. Okay, let me see what I can. Let me see. Let me find an example. Um, is there such things? Wait. Okay. Let's try copper 2 carbonate. Is that such a thing? Copper 2 carbonate. Okay. Let's do what we do. So go periodic table. Check which one is the metal. Wait. Wait. Okay. Copper. The chemical formula for copper is Cu. Okay. I see you. See you is right over here, and it's to the left of the chair. Of the stairs. So that is a metal. Okay. Carbonate is a polyatomic ion, so you must remember the chemical formula for that. Okay. Copper 2. 2. What does the 2 stand for? 2 stands for the charge. So it's copper 2 plus. Okay. Now what's the chemical formula for carbonate? Carbonate is CO 3 2 minus. Yeah. CO3. Yes, CO3. Because if it's CO2, then it's carbon dioxide. Okay. So and it's perfect because copper 2 and carbonate have the opposite charges. So by that logic, we would only need one atom, one of each. Yeah, that's what I'm saying. Okay. Wait. How am I gonna draw dot and cross again? Okay. Yeah, actually I don't know how to draw a dot and cross diagram for this because it wasn't taught. Okay. You know what? Let's just. Okay. Yeah. I guess that was a very quick revision for transition elements and polyatomic ions. If you didn't watch the previous video, I recommend you go watch the previous one, and then you would learn about the transition elements and the other polyatomic ions that you need to revise. Yeah. Okay. So that's it for ionic bonding in this video. Let's skip right to what? Covalent bonds. Covalent bonding. Wow, my handwriting so nice. I don't like that. Okay, can. Okay. Let's start with the simplest compound I know, which is water. Okay, what is water? The chemical formula is H2O. Okay. So let's see. Oh yeah, I forgot to start with introduction. Okay. Introduction of covalent bondings. Covalent bonds only occur in non-metals or between non-metals. This is NM, non-metals. Okay. So covalent bonding, the bond itself is formed by sharing of electrons between atoms. So they share, whereas for ionic bonding, ionic, they either give, no, they either gain or lose electrons. So in this case, for covalent bonding, since they share, they would how to say, as a result they would always have more electrons. Yeah, so I guess you could say they always gain electrons. Yeah, but that's not the correct term lah. In exams you must say it is a sharing between two atoms. Okay. Yeah, that's basically the introduction. Okay, so we know that covalent bonding is between a non-metal and non-metal. Okay, so because of that, we don't need to go back to the periodic table to check if it's a metal or non-metal, because we know that both of these are non-metals. Okay, so the what's the second step is you need to figure out the electronic configuration of both atoms. Okay, so hydrogen is 1. That's the easiest because it has 1 electron. Then oxygen has, let's see, oxygen has 8 electrons. Okay, so the first shell will always have 2 electrons if it's full lah. The first shell can only contain a maximum of 2 electrons. Okay, so once you have 2, we have to find the others, which is 8 minus 2 is 6. Yeah, is the method that I showed you in the previous video. Okay, so 2 and 6. So if you add 1 to 6, it will only become 7, right? So you would need another one more. Another one, yeah. So you need another hydrogen to get 8. And that is why the chemical formula is H2. 2H, 2 hydrogen. Okay, so now we know that there's 2 hydrogen lah, just to make it more clear. And we must keep that in mind when we draw the dot and cross diagram. Okay, so for this dot and cross diagram is a bit different from the dot and cross for ionic bonding. Okay, let's start with oxygen, and let's usually for covalent bonding, they will only ask to show the valence electrons, the outermost shells. Yeah, so let's do that. That is an ugly circle. Let's try again. Ooh, okay, that's kind of okay. Okay, then now we shall draw the electrons. I'm gonna put X because I don't get confused by so many circles. That is 4, 5, and 6. 6 electrons, okay? And then now we draw 2 hydrogens. So, since covalent bonding is 2 atoms or 2 or more atoms sharing electrons, since they share, right, they this is how I remember. Okay, so this is a stickman and his best friend. Okay, so since they are best friends, they would skip together. Skip like they jump up and down while walking, right? So since they are such best friends, they would interlock their hands. So the thing you need to remember is in covalent bonding, they interlock hands. So if you are in Sec 4 Express, you would have learned what a Venn diagram would have been. You would have learned what a Venn diagram is. So this is basically something like a Venn diagram. Okay, so you will draw another hydrogen atom, but you will draw a hydrogen atom, but this time the hydrogen atom must interlock with the oxygen atom. Okay, let me draw that nicer. Okay, that's good enough. It must interlock. Okay, and another hydrogen on its other arm. Okay, and now we okay put the symbol. Okay, now we put the electron on the electron shells. So hydrogen is a circle and it only has one electron, and same for this. Okay, now that we have the electrons in place, we need to show that they are sharing the electrons. Okay, so you can see um, okay, okay, wait, never mind. Okay, so we need to share the we need to show them sharing electrons, right? So what is one area that that is like an overlap that they both have in common, an area that both oxygen and hydrogen have in common? The area is this part. You see the overlap here? Yeah. So to show that they are sharing electrons, we put the electrons in the overlap. So we draw one circle and one X, and one circle and one X. Okay, now it will look, I would say it will look perfect. You know why? Okay, let's go. 1, 2, 3, 4, 5, 6, 7, 8. The oxygen now has a full electron shell because it has 8 electrons in the second shell. So, since it's a second shell, it's full. And as for the hydrogen atom, it has 1, 2. So since hydrogen, this shell is the first shell and it has 2 electrons, the hydrogen, the electron shell is now full. Because remember, we have to go back to the basics. The first electron shell can hold a maximum of 2 electrons. So since this electron shell, so since this electron shell is the first electron shell and it already has 2 electrons, it is now full. And same for this hydrogen atom. So as we can see, all 3 atoms have a full electron shell, and that is what covalent bonding is for. Ionic and covalent bonding, all I would say the purpose of having these bondings are to make the atoms have a full electron shell, whether they lose electrons, they gain electrons, or they share electrons. To gain a full electron shell, they do one of these 3, which is to lose, to gain, or to share. And covalent is to share. Okay, so that's an easy example. We'll do one more. Actually, yeah, covalent and ionic, the dot and cross is pretty easy once you understand. Okay, let's do. Let's see. Oh, after this, I will cover the the properties of each bondings. Okay. So okay, I will choose a compound from organic chemistry. So if you're not a Sec 4 Express student, actually I'm not sure if NA or NT does study this, but I'll just cover this lah. Additional info if you don't study. Okay, so if you're a Sec 4 Express student, you would have learned organic chemistry by now, and they might sometimes overlap. They might add more than one topic or one chapter in one question. So one question might have multiple different chapters lah. So sometimes they would ask a covalent to draw a dot and cross covalent bond of methane. I'm not gonna get too deep into what methane is, but it is an organic compound lah. Okay. So what is the chemical formula of methane? So I'm gonna apply some organic chemistry knowledge. So if you haven't learned that, just bear with me. Okay, so meth. The prefix meth. You have to there's not much how to say logic behind this. I say you just have to memorize lah. Okay, so the prefix meth, it stands for one. Okay, and then the suffix in. What other what functional group ends with in? That's right, alkane. Now don't get confused with alkene. If it's an alkene, it would be methene. But however, for this one, it's methane. Okay, so so by knowing this prefix and suffix, we can thus deduce one. We can deduce one, the number of carbon atoms in this molecule, and the functional group of this compound. Okay, so meth, the prefix of the word always tells us about the number of carbon atoms. So since it's meth, we know that it has one carbon atom. So just put it here. Okay, one carbon atom. And what is the functional what is the, oh no, I forgot the term. Let me check. Is the formula of the functional group, if I'm not wrong. Okay, let's see if I'm right. It's the general formula. Okay, so my bad. So what is the general formula of an alkane? It is CnH2n. Let me just check and like double check just in case I'm wrong. Yes, I'm right. Okay, thank God. Okay, I didn't revise organic chemistry before going through this, so oh, that was risky. Okay, yeah, that is the general formula of an alkane. Okay, so now we just apply this formula to this example lah. Okay, so see the n over here refers to the number lah. So we know that there is only one carbon atom. So thus n equals 1. N equals 1. Okay? So you just substitute we substitute n with 1, which would then become C1H2 times 1. What is 2 times 1? 2. No. Wait, hold on. Hold on. Oh no. I was wrong. Okay. Backtrack. I checked my notes wrongly also. I confused an alkane with an alkene. Ayo, that's embarrassing. Okay. The general formula of an alkane in CnH2n plus 1. Okay? So it's the same same thing as before. The n is the number of molecules there are, number of atoms there are. So in this case, it's meth, and meth is 1, so n equals to 1. My equal sign is so... That was so embarrassing. Okay. N equals to 1. Okay. So it would be C1. And then 2 times n, it will be 2. So 2 plus 2 is 4. Quick maths. Okay. So C1H4. but we can just simplify it to CH4 because we don't need to show that we don't need to show if it's a 1. So the general formula of a the formula of a methane is CH4. Okay, I really need to revise my organic chem. I just burped. Okay, so the formula of a methane is CH4. Okay, now let's look at the covalent bond, the dot and cross diagram of methane. Okay, a bit more into organic chemistry. We learn how to draw the we learn how to draw what is it? What is that called? Okay, let me check again. Let me see if it's in my notes. No, it's okay. We learn how to draw the structure of the organic compounds, and we learn in our notes it shows something like this. Okay, now this so what the okay, so this is the structure of methane. So what I want to say is this structure we can translate it into a dot and cross diagram. How? Okay, simple. Okay, before that, let's go check periodic table. Let's look at the number of electrons they have. Carbon has 6, hydrogen has 1. Okay, so we go back. Okay, so carbon has 6, so 6 minus 2 is first electron shell, so it's 4. 4 minus 8 will give a negative number, so you cannot do that. So we know that carbon has only 2 electron shells, and the second electron shell only has 4 electrons. 4 electrons, okay? So let's just draw carbon first, okay? So circle for carbon. And one tip I have for you is always draw the electrons far apart, as in like how do I say this, don't just just try to how to say just fill up all the sides of a circle. I know it sounds stupid saying sides of a circle when a circle has no sides, but as in like, you know, there are 4 sides where the electrons can be 1, 2, 3, 4, right? So just try to make sure that all the electrons are just try to make sure all the sides are filled up. Don't leave one side empty. Yeah. Okay, so now that we've drawn carbon, we want to draw the hydrogen. And again, carbon and hydrogen, they are best friends, so we'll make sure they interlock. Every hydrogen atom will interlock. And I'm drawing 4 hydrogen because again the chemical formula of methane is CH4. H4. 4 hydrogen. Okay? Alright. And then we will just put the electrons we'll put the electrons in the common area where the atoms overlap, which are here, and here. Okay, so I'm gonna erase the excess because they are on the line, but they are on the line but not in the common space. Yeah. Okay, so X for carbon, circle for hydrogen, X for carbon. Okay, now do you see a resemblance between this diagram and this diagram? This diagram. Right, so the arrangement of the atoms are exactly the same. In fact, one line here represents the bond between one X and one circle. And in covalent bonds, there must always be the same number of X's and circles in one like overlap. You get what I mean? So one X, one dot in one overlap. One X, one dot in one overlap. One X, one dot in one overlap. Sometimes in some compounds there will be two X's and two circles. Oh, there's a bit. Sometimes there might be X circle and another X circle, and that's perfectly fine. Let me find an example with that. Carbon dioxide. Carbon dioxide. Okay. O C C brother. Okay, so oxygen has 6 outer ones. Let me put X. 1, 2, 3, 4, 5, 6. Okay, so you copy that here. So we make sure it's this, because it's like this oxygen, you know. Okay, and then carbon has 4, like just now. So 1, 2, 3, 4. You see how it still matches up? Because we have 1, 2, 3, 4, 5, 6, and then another 2, 7, 8. So full electron shell, which would be the same for the other oxygen atom. 1, 2, 3, 4, 5, 6, 7, 8. And for the carbon, 1, 2, 3, 4, 5, 6, 7, 8. Yeah. And notice how it's 2 X's and 1 dot. 2 X's and 1 dot. Well, 2 X's, 2 dots. 2 X's, 2 dots. Yeah. Because, again, one line represents one bond. So you could say that there is a double bond between carbon and oxygen, because 1 and 2. So there's a double bond between carbon and oxygen. And back to organic chemistry, we always hear this term called a double carbon bond. So let me just show you a double carbon bond. So at no, that's too much. This must be X. Okay, so a double carbon bond is not it doesn't have a full electron shell, because a carbon bond is never alone. But so in organic chemistry, we learn this structure. This should be an ethane molecule, if I'm not wrong. I think this should be this is ethene molecule. Okay, so if we focus on this part, this carbon double bond, which is this, it is basically this carbon carbon-carbon double bond. Yeah. And then I can move this electron and this electron over here and over here, and then we can basically complete it now. H and H and this too small, and H, and then yeah, I'm not gonna do the rest, but you see, it's the same thing also. So that's the beauty of organic chemistry and covalent bonding. And with that, I shall conclude the dot and cross diagrams between the dot and cross diagrams of ionic bonds and covalent bonds. Woo! Everybody clap your hands. Okay. Now let's go to the properties of each bond. This is all just memorization work now. So okay. So let's talk about okay. Acid reflux. Okay. Let's talk about sorry. So many okays. Ionic, covalent versus. Alright. Let's talk about the physical state. So either it's a solid, liquid, or gaseous, or it can also be aqueous or molten. But we'll talk about aqueous and molten in later in this part. Okay. So ionic compounds, they are usually okay, let's make a smart guess. Okay, so what we learn in we can't make a smart guess because I haven't taught you all. Okay, never mind. Let's just use a keyboard since it's easier. Okay, they are usually crystalline solids. Is that how I spell crystalline? Yeah, crystalline solids. Oi. Oh no, I just leaked my mother's iPad. Pretend like I didn't say that, please. Like legit. Don't go back. Wait, let me check. Can I edit this? No, I can't. It's already too late. Okay, never mind. Usually crystalline solids at RTP. Okay, what is RTP? RTP basically stands for room temperature and pressure. Okay. So what is a crystalline solid? What is a crystalline? Huh? Okay. So crystalline is basically the molecules are arranged in a very neat and orderly manner such that it becomes when it repeats for enough times, it looks so real. Oh no, what am I talking about? It looks so pretty, I guess. Okay. Okay, wait. I'm gonna pause. I'm gonna look for a reference image from Google. Okay. BRB. Yeah, BRB.